Hi and good morning to Dr. Liu. This is the lab report presentation from Group 6 for the experiment of linear momentum. And this is my fellow group members. Experiment 5, linear momentum. This is the objective and the apparatus for this experiment. And this is the procedure.
First, record the weight of glider 1 as M1 and glider 2 as M2. Place glider 1 and glider 2 on the air track. Release M1 so that it will strike M2. Record the time once the flag passed through photogate 1 as T1 and photogate 2 as T2. For each trial, take off another 0.02 kg of M1 and record the T1 and T2 obtained.
Now, we will be explaining about the calculations.
First of all, we can label all the data so that it will be easier for us to calculate it. Next, we can find the initial velocity by using formula of displacement over time taken. Next, we can find the final velocity by using the formula of mass multiplied by initial velocity n equals to final velocity multiplied by total mass. Then we can rearrange the equation to get the final velocity. After that, we need to calculate the initial momentum with the formula of mass multiplied by initial velocity, and the unit is kg/meter per second. Lastly, we have to find the final momentum with the formula of total mass multiplied by final velocity. The initial and the final momentum are the same, which means it is conserved. Next is data 2. For all the calculation, it is the same. We have to find the initial velocity, final velocity, initial momentum, and the final momentum. As for the initial momentum, it is 0.091 kg/meter per second. And for the final momentum, it is 0.090 kg/meter per second. And the initial and the final is not the same, it is not conserved. For data set 3, the initial momentum is 0.08724 kg/meter per second. As for the final momentum, it is the same, it's 0.08724 kg/meter per second. And the initial and the final are the same, it is conserved. Next is data set 4. The initial momentum is 0.084 kg/meter per second. And the final momentum is 0.082 kg/meter per second. The initial and the final is not the same, it is not conserved.
To find the percent difference, we are using formula experimental value minus with theoretical value divide theoretical value times with 100%. Data 2, 3, and 4 will be calculated using the same formula. The higher the percent difference, the higher the number of errors that have happened during the experiment. For question 1, is linear momentum in this experiment is conserved? The linear momentum is conserved in this experiment. This is because there is no external force acting on the system such as friction force due to the use of air track in the system. Linear momentum is also considered conserved when the initial momentum and final momentum is equal. Therefore, for data 1 and 3, the linear momentum is conserved, whereas for data 2 and 4, the linear momentum is not conserved.
Is energy conserved in the collision? No, the energy in this experiment for all set of data is not conserved. This is because the initial kinetic energy is not equal to the final kinetic energy. Since the initial kinetic energy are more than final kinetic energy, this indicates that the type of collision in this experiment is inelastic collision. As for the calculation, we are going to use the formula of delta kinetic energy. So the conclusion is the experiment shows that linear momentum is conserved during the collision because the total momentum before and after the impact are nearly the same. However, the energy is not conserved as the result shows a decrease after the collision, indicating that it was inelastic. Thus, the momentum was conserved while the energy is not.
And that is all from us. Thank you.